Hi class, this is what we have today, lesson 3 of inequalities, linear inequalities. We want to see how we show this one on number lines. Yeah, how do we graph them on number lines? Okay, the first one is x greater than minus 3. X greater than minus 3. But let me tell you first that this one is greater than, basically this one is less than, this one is greater than or equal to, this one is less than or equal to. So for the one that says greater than, the number line goes like this. And for less than, the number line goes like this. So you can see greater than, the number line goes like this. Less than, the number line goes like this. Yes. So this is greater than. How about greater than or equal to? Well, the same thing goes this way, but it appears as if they are the same. What is the difference now? The one with equal to, it is shaded here. It means the value itself is included. This one means the value is not included. So less than goes this way. And how about less than or equal to? We include the value. So let's see how we graph x greater than minus 3. X greater than minus 3 simply means a particular number greater than minus 3. Now let's see the number line here. We have 0, 1, 2, 3. Negative 1, negative 2, negative 3, negative 4. Then it does not end. That means to negative infinity. Yeah, we assume this one is positive infinity. All right. So where is minus 3? Minus 3 is here. Minus 3 is here. With this minus 3, what does it say? Greater than minus 3. But let's forget about number lines. Let's come to something important, basically. You can see 0 is a neutral. When you say 0, it is neither negative nor positive. But once we say a number is positive, it means it is greater than 0. Once we say a number is negative, it means it is less than 0. Then note that for the number line, this way the numbers increase, and this way the numbers decrease. So if we are saying this way, the numbers increase, the numbers are increasing this way. So it means since 1 is away from 0, so meaning 1 is greater than 0, 2 is greater than 1, 3 is greater than 2. So once 3 is far off as compared to 1, meaning 3 is greater than all these numbers. 2 is greater than all what is there. So even if we go to negative 1,000, negative 1 million, these 2 is greater than all of them, because this way the numbers increase, this way the numbers decrease. So if I may ask, how do you compare 0 and minus 2? Which one is greater? Well, 0 is on the right, minus 2 is on the left. So 0 is greater. You need to understand this. Now, how do you compare negative 2, positive 2? This one is on the positive side. This way we are increasing. This way we are decreasing. How do you compare 0 and negative 4? Which one is greater? 0 is greater because we are increasing this way, we are decreasing this way. So it's like 3, you are decreasing to 2, you decrease to 1, you decrease to this, you decrease to this. So do not say, well, how about minus 2 and minus 4? Is minus 4 no greater because of 4? No, because minus 2 is closer to the positive side than what? The minus 4 is closer to the opposite side, positive side, as compared to what? Negative 4. So it means this one is greater than this. In a very simple way, just consider the one on the right is always greater than the one on the left. That one is so easy to understand it that way. Okay, now let's see how we show inequalities on number lines. Now, -3, try to identify it first. Look at -3. This is talking about greater, a number greater. Remember, numbers on the right-hand side of a particular number, they are always greater. Now, 2 is on the right, 1 is on the left. So 2 is greater. 0 is on the right, -2 is on the left. So 0 is greater. So once we are considering numbers greater than -3, it means we are moving that way. So we are what? Moving this way. Yeah, we are moving this way. But when you are representing number line, it doesn't mean that you have to stop here. The most important thing, you are moving that way. Yeah, but most times we get to the level of the arrow, most times. Yeah. But if I may ask, what are the numbers greater than -3? I just told you that the one on the right is greater than the one on the left. Okay. Numbers greater than -3. Look at them. These are all greater than -3. Are these the only numbers greater than -3? No. Numbers greater than -3 are infinite. There is no end to that. We don't even know the last number. So like to infinity, all those ones are greater. So what is the first number that is greater than -3? We cannot tell. Yeah, because look at -3. Is -3 part of it? No, -3 is not part of it because we are saying greater than. If we say -3, it's like -3 is equal to -3. But we are, okay, this is like, okay, let me take it to positive because it's what most students are familiar with. Let's say 5. Yeah, let's say I have 5 leons. I have 5 leons. So you know exactly how much you have. But saying I have more than 5 leons, I have more than 5 leons. So how much do you have? If I just said I have more than 5 leons, it could be 6 leons. It could be 6.1 leons. It could be 6.000095. So whatsoever leons. So you need to understand this one. So -3 is this, because greater, we move this way. Can we shape the circle? We cannot shape it because we are saying greater than -3. So we don't start at -3. If I have 5 leons, it means I have exactly 5 leons. But if I just told you that I have more than 5 leons, then I ask you, guess how much I have. You'll be saying what? Okay, you have 6 leons. Okay, you have 10 leons. No, you have 100 leons. You have 500 leons. See? So saying greater than 5 meaning what? We are not starting from 5. So the reason we don't shade the circle. Okay, so this is what has been shown for what? Number greater than -3. Okay, so let's go to the second one. The second one says x greater than 2. First of all, identify it, 2. Look at 2 here. This is 2. Are we going this way? No, we are not going towards numbers that are less than 2. For a particular number, the ones on the left of it are less than the number itself. For a particular number, the ones on the right of it are greater than the number itself. So if we are saying greater than 2, we must consider that way. This way. Greater than 2. So we move that way. Can we include this? Can we shade the circle? No. If we are shading the circle, it's like 2 is part of it, but 2 is not part of it. Why? Because greater than 2. If someone asks you, give me 3 numbers greater than 2, will you call 2? No, you will not call 2 because we are saying greater than. The reason we don't shade the circle. Okay, so like in further math or pure math, sometimes we're also concerned with sets. Yeah, sets. The order we are like this. So if we are saying 2, look at 2. Is 2 part of it? No, 2 is not part of it. So we don't even know the first value that is greater than 2. Yeah, you might be surprised. We don't know the first value that is greater than 2. Don't you think that? Because when you are saying a number greater than 2, you have trillions, more than trillions of numbers greater than 2. Yes, because unless if the question is like the first integer, yeah, integer is talking about whole numbers. But otherwise, if we are making it open, like for every real number, well, we have trillions of numbers greater than 2. Okay, because you have to start by saying, well, the first number greater than 2, let me try to guess it like 2.0000. So I'll be writing like billions of zeros and say 1. Then I go again, 2.00000. I write billions of zeros, then I say 1, 2. Then I go again. Just imagine, we have trillions before you even get to what? Before you even get to 3. Okay, so because of that, look at 2. Greater than 0, greater than 2. What is the last number greater than 2? We don't know it. So we say infinity. Yeah. But if we are saying greater than or equal to 2, this one, we know exactly where the number is starting. Where the number is starting, it starts at 2 because not only greater than 2, but also equal. Greater than or equal. So this one will change to this. So this one is telling you that there is a starting point. This one is telling you that there is no starting point, there is no end point. So we call this a closed set, and this one is open. Okay. But for just core math, general math, like how do I call it, preliminary, we only need to discuss this one. Pure math, yes, we can talk about set properly. Okay, so let's go to the third one. The third one is saying x less than or equal to -4. Yeah, look at -4 first. Look at -4. This is -4. Yes, are we considering numbers greater than this? No, we are considering numbers less. So we go to the left of the number itself. So this way. The number starts from -4 or it does not start from -4? It starts from -4. How do we know? Equal to. Not only less than, but also equal to. So therefore, we shade this one. So if you want to represent this one in a set, in a ordered pair of sets, like, does it start from -4? Yes, -4. So it should not be open like this. Look at it. Yeah, to where? To infinity. Negative infinity. There is no end to it. Because when we talk about less than -4, we don't know the end, the last value. So we are only interested in the graph. Look at it here. The next one is x less than 3. X less than 3. Identify what we have. Look at it. 3. So are we going to the greater or to the less? We are going to the less. So we are going to the less. Yes. Is it equal to? There is an equal to? No, there is no equal to. So we don't shade. It is open. So suppose you want to know how to write it in ordered pair of values or coordinates. Now we have 3. We are moving this way. So this one has to be on the right. To where? To infinity. Which part of infinity? Negative infinity. Like this. It is open here. Why is it open? Because saying less than 3 doesn't mean that it's, sorry, I don't even need to say doesn't. Less than 3 meaning it doesn't start from 3. So it is open, and it's also open here. So that is it. But saying graph on a number line, this is all we have. The last one is x greater than or equal to -2. Greater than or equal to -2. Where is -2? Look at -2 here. Yes, greater. For a particular number, the numbers on the right side of it are greater than the number itself. For a particular number, the numbers on the left of it are less than the number itself. So since we are talking about greater, we go this way. We go this way. Greater than, not only if it is greater than, it is this way, but greater than or equal to, well, we'll show this to show that this one is included. If you want to know the sets, well, we have -2. We are going this way to infinity, positive infinity. Yeah, this one is included. So look at it. Here is open. Look at it. So this is lesson 3. Thank you for watching. Don't forget to follow, like, share, and comment. See my next video.